Okay, our next speaker is John, who's obviously been involved with asking the question. So, John, if you can share your screen. John's at the University of Nottingham, and he's going to be talking about finding routes to roots. So, over to you, John.
Yeah, thank you, Geraint. Just stop my timer here. Well, good afternoon, everyone. Yeah, it's great to be invited to a panel like this. We don't have to start with an introduction about, oh, actually, I do it in trees, and so trees are different. So we've already started in that stream, and we're gonna stay in that space. My bit here today is to continue to spread the word of propagation by cuttings in trees, which is the work we've been doing in Nottingham, and it's been largely funded by the Forestry Commission, unless stated otherwise. So thanks to them for the support. But I'd like to start by actually talking to you a little bit about my own journey in this subject, which starts with me as a boy spending my summers at my nan's, and that invariably involved me helping her in the garden. And so that was my first contact with clonal propagation, when she would have a friend come round with a rose bush that was beautiful last year, so she wanted to give it to all her friends. So she would bring a bit of plant that looked dead in a bag with a bit of soil. And lo and behold, a couple of weeks later, I would see my nan planting that out in the garden. And I found that to be quite magical, how you could bring a piece of a plant that looked quite dead, to be honest, and how it could really flourish, how you could just propagate plants like these. And if you cut it to maybe 15, 20 years later, I got the chance to do my own research uh, in clonal propagation in Brazil, where I'm from, looking at eucalyptus propagation. And I'd like you to take a look at this right side panel. Just ignore the very bearded me in the picture, but look at the scale uh, of what we're talking about here. So clonal propagation is the backbone of the eucalyptus cultivation industry in Brazil and in many other countries that plant eucalyptus to the same degree. So after I finished my PhD, I I applied for this job in Nottingham to join Amanda Rasmussen's group, who's actually the convener of the AAB special interest group that sort of motivated today's webinar to look at clonally propagating UK tree species. And one of the questions I was faced with, which is a fair question, but it's quite hard hitting, is why bother? We've been doing it with seed only, and it's been fine until now, to a certain degree. We've been able to explore the genetic diversity afforded to us by evolution. We've been able to produce trees that we plant within and outside of woodlands, and it's also served us to a certain degree well in terms of producing high quality woody products. So why do it? Well, that is no longer the reality we're faced with. We have a constant this constant bombardment of news in terms of a new climate and new trade routes that bring new diseases that once couldn't survive here but now can. And Australia has already touched on a couple of those. And we also are talking about trees that undergo masting, so they don't produce viable seed in large amounts every year. When they do, it's not so easy to keep those seeds. They might not germinate anymore. And so the link between that lovely diversity that we love to work with and the products that it affords us becomes more and more untenable if we don't introduce new tools to face these new challenges. And that's where clonal forestry or clonal techniques come in. And we're not just talking about producing more trees. We have to remember that these trees have to survive. They have to be more resilient. And clonal techniques, even though that name might not ring so good in everyone's ear, uh, these techniques of vegetative propagation, they allow us to better exploit and select elite traits within the diversity that we want to work with. Because sometimes if that diversity includes a lot of trees that are just going to die because of ash dieback or because of acute oat decline, maybe we want to actually reduce a bit that diversity. We want to focus on resistance, or we want to focus on yield or a particular form And we just aren't able to do that currently in the UK. If we introduce propagation by cuttings, for example, as another tool in the toolkit for tree production in the UK, we can also streamline breeding programs. We can produce more trees faster, and we know that this rate with which we produce trees is of the essence. We also know that, like Australia was talking about, each individual you sample is a different genotype, it's a different genome. So even for research purposes, if we could have a clonal population that would then be comparable, so we could do tests to see whether it's the genotype or the environment that's creating a perceived effect, that would be great. So overall, my job here and our job as a group is to better understand and overcome the roadblocks that exist to clonally propagate through cuttings these tree species. And I mentioned all the positive things about it, so if it's so great, why aren't we doing it? Well, if you've tried to propagate something in your house, something woody, you might have gone through the to something that's different from that idyllic story that I told about my grandma, where it just doesn't work. You take a cutting and it just doesn't root. And maybe someone tells you, oh, you just need to go and buy some rooting hormone. You just dip the base of the cutting and it's going to work. And if it does, that's great. And sometimes it does. But especially for very mature trees, it often doesn't. And what you get is just this amorphous growth at the base of the cutting, and you don't really get any roots from there. So there is a lot still to be achieved in terms of logistics to getting these materials to root. And a lot of that research has been done in the past 20 years for eucalyptus, for acacia, for casuarina, for lots of tropical trees, but not for temperate trees. We also have this conundrum where uh, our elite trees, our plus trees, have a certain form and a certain aspect, but that aspect can only be diagnosed when the trees are 50, 60, 70 years old. When the trees are that old, it becomes very, very hard, near impossible to propagate them by cuttings or even grafting. And on the other end, you could use saplings as a starting material for propagation, and then you could propagate them quite easily, but then you don't know what you're propagating. Because say from ash and some other maybe plants of interest, we lack those breeding markers that would allow us to do early selection. Because if we could do early selection, then we just grab the easiest to propagate material, genotype it, and then propagate it massively, right? We don't have those tools for lots of UK species. And so it's within this knowledge gap that we work to try to bridge it, to try to bring these technologies to UK tree production. So how do we work? We collect material from woods that we have access to, either ourselves or through our partners. One of the main ones is Future Trees Trust. We treat them with different rooting hormones or different molecules of interest. We pot them, keep them under high humidity in a glass house, and then we assess them for rooting. So what can I say now that it's a bit less doom and gloom, that there are some good results that we achieved on our first run of the Tree Production Innovation Fund provided by the Forestry Commission? Well, our friends at NIAB, East Malling, were able to get some pretty good results with ash seedlings, getting up to 65% rooting, but also some with mature, and by mature here I mean sexually mature, so grafted trees that are able to flower, to produce seed. Those numbers are much smaller, as you'll see in the next slide. So we're talking about just over 10% success. But in Matt's case, because he's working with materials that he knows for example, he knows how resistant to dieback these trees are. If he knows that for the seedlings, if he knows what material he's working with, it doesn't matter if he's using seedlings. He can use seedlings because he knows enough about their genotype. In our case, if we're just going out and collecting from a beautiful oak tree, but that we know nothing about, that becomes much harder. We're working mostly with ash and oak, and so we had to ask ourselves, are these good representatives of what it's like to propagate UK trees? Because they were really hard to propagate. So we got Vaishali, a great PhD student we have in our group, to do basically a panorama of UK species. She collected lots of different cuttings from different species, all around the same age. And she found this sort of distribution along this rootometer axis that you can see. Well, you can see that the distribution is skewed towards failure. Most of these species aren't so easy to propagate. And then you also have the outliers like willow, like dogwood, that are really, really easy to propagate by cuttings. And you find some in the middle. So we also asked ourselves, can it be improved by a simple treatment? A treatment that's not so far detached from what you can do at home with a rooting hormone dip. And that's what we did. And in fact, for some tree species such as lime, maple, beech, alder, we did see variable results, but for example, for beech, it was a massive improvement coming from near zero to near 80%. And this is something that we are repeating, of course, to see whether it was a fluke or if it's something that we can consistently rely on. And we've been seeing positive results with beech. So there is a lot that can be improved with very simple techniques, but there are some, like oak, like ash, and apparently like hawthorn and hornbeam, which are going to take more research to actually crack. Talking about oak, so what do you do if none of your cutting is root, right? So what's going wrong? You're giving them different levels of rooting hormones. What's happening? One of the reflections we had to go through is, okay, we're giving them a certain level of rooting hormone, but are they even taking up that rooting hormone solution? And you might think, even if you have never read anything about this, surely someone will have looked into it, right? Someone will have proved that at least you can trust that the rooting hormone goes in. Well, it turned out no one had. So what we were doing, even though it was quite basic, it was groundbreaking, just proving that the rooting hormone actually goes into the cutting. So what we did was treat these oak cuttings with either the control solution or different concentrations of the rooting hormone. I'm going to be talking about two different forms of auxin here. IBA is one of the main ingredients of commercially available rooting hormones, and that's what we used. And we also exposed the cuttings either for 1 minute or for 15 minutes to see whether that made a difference. And then at different times after the exposure, we sampled just the base of the cutting, which is the part that was exposed to the rooting hormone, and also where we would expect the rooting hormones, even the endogenous ones, to accumulate. We ground that up, sent it to the School of Pharmacy so we could quantify how much of that hormone actually went in. And here are the results. So IBA, again, I'm talking about the rooting hormone that we apply on the outside. And lo and behold, the more you give, the more IBA you give these cuttings, the more IBA you find inside them, which is good, right? But hadn't even been shown to be true. And it's only true to a certain extent. You can see that if you use the highest concentration, especially at the longest period, then you do get a massive increase in what you get inside the cutting. Now, what's interesting is, remember, this led to no effect in rooting. So you do get that burst of IBA, but it doesn't lead anywhere. It doesn't lead to rooting. So that got us thinking, well, what about the actual auxin, the canonical active auxin inside the cutting? Because IBA is not that. IBA can be transformed inside the plant into IAA, indole acetic acid, which is the active auxin, which is the auxin form that will bind the receptor and trigger root formation. If you look at the ribbons now, you can see that they're much closer together. So giving orders of magnitude more IBA to cuttings will give you that much more IBA. But if you look at how much IAA, how much active auxin is inside the cuttings, you just don't get that same bang for your buck. You just don't get that increase. So that might be one of the underlying reasons why we don't see roots. This conversion from IBA to IAA might be actually what needs work on, not necessarily just flooding it with auxin. And this was something new that we were able to see for the first time because we went back to basics and wanted to check whether any auxin was actually getting it. Going back to our titular question, so can we propagate these species by cuttings? Yes, I'm a firm believer, otherwise I wouldn't be here talking about it. I'm a firm believer in it, but it comes with a lot of asterisks, right? It should be taken on a case-by-case approach. Just because we can propagate something by cuttings, it doesn't mean we should. It depends on the production demands, for example. It depends on how much the seed propagation route needs help from the cutting propagation route. we have to reckon with the fact that age is still a massive problem if we want to make this into a more sort of streamlined process. And we need to understand what it is about age. And here I'm making a very clear nod to Australia, and I think she actually has some data that could help us, is there's something about the aging process that makes it harder to propagate trees. And we've never been able to pinpoint what it is that causes uh, this decline. So understanding that decline might be the key to unlocking the propagation of older material, but that's something for me in Australia to talk about later. Uh, and just to show that there's hope, what you can see here in this very dirty and wet glass house, because that's the reality of it, is some root tips coming from the bottom of a tray. So this was taken just over a week ago, and these are cuttings taken from a beech tree that was definitely over 30 years old. So that's the oldest beech we've been able to clonally propagate. And we're pushing that barrier, which is making our partners really happy, because then we're getting closer to when you can actually say, this is definitely a beech tree that I want to clone. I want to get more of this. That's what we're pushing towards. And how we're going to do that is basically with renewed funding from the Forestry Commission. We're going to finance our protocols for broadleaves that are sort of in the middle or towards the easy end. So we have protocols ready to go for people that want to propagate tree species by cuttings in the UK. We're going to use beech as sort of our halfway point that we can turn it, we can possibly modulate it so it roots better and worse, so we can see what causes what. And we're also going to do much more detailed work in oak, which is the one that provides spreadsheets full of zeros. But we want to understand, for example, the effects of the timing of floral set bud on whether you're going to get roots or not from a cutting, and also some metabolic and molecular markers that could help us understand the difference between a cutting that roots and a cutting that doesn't root. I'd like to thank Mandy, my supervisor, Vaishali, who did all this great work with other species, also the people at NIAB, Future Trees Trust, and our funders, Forestry Commission. Also very hardworking teams, technical teams in the Hounsfield facility, and the Glasshouse team at the University of Nottingham. And also you for paying attention for me, paying attention to me banging on about this, as I always do. And I'm happy to answer any questions you might have.
Thanks so much, John. That's very interesting stuff. Good to hear there's follow-on funding being provided, so you can keep looking at this. So we have a question from Alice in the Alice Jones in the chat. She says, very interesting. And regarding mature material, do you mean the overall age of the tree or of the wood taken for the cutting? So, for example, if we coppice old trees to make fresh new growth, do they perform better or not? Do you know?
They would perform better. Now, we don't know why. We've known this for hundreds of years, that coppicing works, right? The problem with coppicing for this is if I tell Joe Clark, she points to me to like 100-year-old and says, I want to clone this. And I'll say, yes, just give me a chainsaw and I'll clone it for you. That just doesn't work, you know. But it is part of what people do, for example, for eucalyptus. So when eucalyptus reaches the end of the season after 7, 8 years in Brazil, what they do is they fell them and they leave the stumps to resprout. And then they use that material as initial clonal material for the next run because it's the easiest way of getting very good, vigorous material that somehow acts young, even though it comes from a very old tree.
Okay, we have another question from Romaine. She says she's new to the world of propagation, but was wondering if there's any major differences between broadleafs and conifers to propagate this way. And that was kind of linked into a question I was going to ask, whether the solutions that you're using, your rooting solutions, that say if there's any differences in general with kind of horticultural crops and things like that that you might the solutions you might use.
So that's a good question. What we see in terms of conifers versus broadleaves is that there's much more information available for conifers, especially pine, for example, for a lot of different reasons, for a lot of interest in New Zealand, Australia, Mexico, the US. There's been a lot of research into clonal propagation of pines, for example. Some of them, they produce so much seed and they grow so fast compared to broadleaves that cutting propagation is sometimes just not considered as as big an advantage. But for pines, you can definitely see that there's a rich history, and I think even Mandy during her early career worked on pine propagation. So yeah, there's they both can benefit from clonal propagation, but there will be particulars in terms of conifers. Uh, but two different broadleaf species could be as different from each other in terms of what treatment works as a species of broadleaf and a species of conifer. It's that specific. Now, in terms of horticulture, yes, but horticulturalists are so much far ahead in terms of propagation because they do this all the time, especially ornamental horticulture. And there seemed to be a, a lack of connection between forestry and fruiticulture, for example. So apple rootstocks are propagated by cuttings all the time. So there's a lot of knowledge there, but it's a lot of empirical knowledge that often doesn't get published. The same thing goes for ornamental willows, ornamental birches, so yeah, there's a lot to be learned there. And whenever we go to a nursery, we always learn something new, but that is kept as that sort of practical knowledge that we just don't see in the papers.